So now we're going to start talking about doors and windows, the fundamentals of energy efficiency as it relates to these kinds of things which we refer to as fenestrations. Fenestration is a fancy way to say window, door, or skylight. Fenestration is an intentional hole in a building where you put a window, a door, or a skylight. It's just that simple. Fenestrations affect comfort in three primary ways, and those three primary ways are, in essence, the same as the way that buildings lose or gain heat. Radiation. We all know that radiation is one of those ways, okay? So when we look at a window or a door or a skylight, we see that radiant heat from the sun primarily comes through into the house, radiates onto the floor and warms the house, warms your furniture, warms your cat or your dog or whomever, okay? Well, interestingly enough, windows also work in the reverse. They take the heat that's in your house, particularly at night, and that heat inside the house radiates to the outside through that same fenestration, door, window, or skylight. Another way that these doors, windows, and skylights, these fenestrations affect comfort is through infiltration. When we were at our house on Monday, we talked about the windowsill and checking underneath the windowsill for caulking. Okay? You folks who have experience in construction, you know, a properly installed window goes into the rough opening and then gets sealed all the way around. That's usually when people start laughing hysterically, right? We understand how buildings get built, and we like to build buildings as quickly as we can, because the faster we get a building built, the less money it costs us to build. So consequently, we have a rough opening, we throw the window up in there, we make it sure that it's plumb and true and square, and then we nail it down and away we go. The last thing that we want to talk about is actually the convection, okay? The convection that's created by the window. That cold surface makes that air cooler. The air gives up its heat out the window and begins to fall faster, because we know warm air rises, consequently cold air sinks, right? Falls. So as that air is giving up its heat to the window, it begins to fall at a faster rate. It's hitting that windowsill and blowing out across the homeowner, right? Usually they've got that couch. So pay attention as building analysts of where the homeowner has their furniture. Interestingly enough, something else that you'll discover is that building professionals, they understand this problem of convection and the cold air dropping down across a window. Consequently, you'll find a lot of heat registers and forced air systems directly underneath a window. In a lot of cases, not every case, but a lot of cases, that's what you'll find. And the idea is we're going to have this warm air coming up, and it's going to counter the cool air falling. Okay? And then there's the couch that's sitting over the top of the register, so that, right? Okay. You see what I'm saying here. When you look at a window, you're going to find one of these window stickers. And on that window sticker, you're going to have 5 pieces of information: U factor, solar heat gain coefficient, visible transmittance, air leakage, and condensation resistance. Okay? Now, we've already talked about U factor. What is U factor again? It's a measurement of heat transmittance. R factor is resistance to heat transmittance. U factor is heat transmittance, right? Okay? You think of in electrical, a insulator versus a conductor. When we look at windows, it's interesting the way windows are marketed. We don't market windows with R value. We market them with U value. And what that does for the average person is it obscures the fact that the higher the U factor, the smaller the R factor. Right? It's because most people think more is better. So here you are. You're talking to a homeowner. And the homeowner is telling you that the windows sales guy was out and they're going to give them a really great deal. For $10,000, they're going to double the R value of their windows. Okay, well, their windows were R1, and we're going to double it to R2. What do you think? If you did the SIR, do you think that would be an SIR of over 1? Not even close. Okay? So, your job as an energy efficiency expert or as a building analyst, a energy auditor, is now to educate the client on all of these things, okay, so that they understand what's going on. U factor is a measure of transmittance, thermal transmittance. How well does the window transmit heat from one side of it to the next? Okay, that's U factor. Now let's talk about solar heat gain coefficient. Now, solar heat gain coefficient is the ratio of solar heat that's passing through the window relative to the total amount of solar heat available. This includes the solar heat that goes through the window, as well as the solar heat that's absorbed by the window panes themselves and then re-radiated into the house. Okay, it includes both of those things. Solar heat gain coefficient. Visible transmittance, on the other hand, is a measure of how opaque the window is, how much visible light comes through the window. Now, when we're talking about heat, we're talking about the IR spectrum, right? We're talking about the reds, the long wavelength light. That's the stuff that warms you up. But when we start talking about visible transmittance, we're not just talking about the reds, but we're talking about the yellows, all the way up through the blues and the violets. Okay? That's visible transmittance. So what are some of the things that you can do, or the homeowner can do, or that can be done to fix problems related to installation? For example, the window was installed without any kind of air sealing in the rough opening. What can we do? So we can go outside the window and we can do what this lady in the red shirt is doing, and we can caulk around the outside of the window and make sure all of those gaps are caulked. What else can we do? We can pull the trim on the inside. We pull the trim on the inside and then we can stuff it with fiberglass really nice and tight and then finish it up with some foam. Okay, so then we get both a barrier of, we get a thermal barrier and we get an air barrier, right, on the other side. So that works really, really well. Or the last thing you can do is, without pulling the trim, we can actually simply go around the trim on the inside of the window, on the inside of the building, and caulk the trim work everywhere the trim comes together, everywhere the trim touches the drywall, everywhere the trim touches the window. There's also one other product that's very, very interesting that I personally like, and it's called Weatherstripping Caulk. And it's not like normal caulk in that it can be removed. So let's say you've got a leaky window. Your homeowner has a leaky window and they don't have the money to replace it. They can go down to the hardware store and pick up this weather stripping caulk and caulk the window shut. But when it's time, when it gets to summertime and they want to open it, it just peels right out. The weather-stripping caulk just peels right out, and you can open the window, and the window becomes operable. When you have heat transmittance through the frame of the window, putting caulk or putting insulation around the window is not going to stop the heat from traveling through the frame of the window. The only thing that's going to do is we're trying to stop air from moving in through the rough opening of the window. But in a minute, we're going to talk about what to do about those wonderful aluminum frame windows, right? Which are just, I mean, aluminum is so good at transferring heat. I mean, they make heat sinks out of aluminum. It's so good at moving heat, right? You got something that's too hot, you pop an aluminum heat sink on there and you're golden, okay? But here we made windows out of it, right? We made these window frames out of aluminum, and they are very, very efficient at pulling air or pulling heat out of our house, okay? But we're going to talk about, in just a minute, we're going to talk about what to do with that. Now let's talk about stopping air leakage around doors. We need to make sure that the weather stripping gets installed properly. The corners are nice and tight. We make sure we're using door sweeps. In my opinion, the best kind of weather stripping is the kind of weather stripping that seals against the face of the door. So the door comes and closes, and the weather stripping seals against the face of the door. That's heat loss. Let's talk about heat gain through window. How do we control heat gain? So we control heat loss by putting an insulated window shade on the inside of the window. But when we go to architectural shading, we use architectural shading to stop heat gain through a window, okay? Properly done architectural shading will give you shade in the summer and no shade in the winter. Most people call those things trees, deciduous trees. In the summertime, here they are, they got their leaves, they're hanging out, they're providing nice shade on the south side of our house for our windows on the south side of the house. And then it starts to get cold, and the tree starts to get cold, so it starts dropping its leaves. Guess what? When the tree starts to get cold, so do we, right? And consequently, now all of a sudden, on our south-facing windows, we have lots and lots and lots of sunshine, okay? And it's warming us up, and we have our house. We have passive solar, right? Passive solar heat. We can also do this with the eaves of our building. If depending on what our location is on the earth and how tall our building is, that'll determine how long our eaves are, so that when the sun is low on the horizon during the winter, we get sun, but when it's high in the summer, we get shade. We can do that with an awning. We don't have to have the eaves sticking out that far. We can actually have an awning. And you know, if we can afford it, of course, we can even do a motorized awning. That's retractable, yeah. So all of those things contribute to reducing solar heat gain. What do we do if we want to reduce the air leakage around our window through the rough opening? We can caulk the outside, we can caulk the inside, we can pull the trim and put insulation and foam around inside that rough opening between the fenestration and the rough opening to stop heat loss on the inside of our building. We can add insulated window coverings like multi-cell blinds or quilted drapes. We can stop air leakage around doors by installing new weather stripping. We can also help that using a storm door, because when the wind blows on our door, the storm door will take the brunt of that wind. And of course, it's not going to be airtight, so we'll get air around the storm door, but we don't have the same level of pressure, the same sort of force up against that door, because usually a front door is going to open to the inside. So when the wind blows against it, it's trying to blow that door open, which is going to push it away from our weather stripping, allowing the air to come around. We can use architectural shading features like awnings, like long eaves, like deciduous trees to provide shade during the summer and passive solar heat gain during the winter. The other thing that also want to make sure that you are paying attention to, especially when you're doing auditing and you have a house that has a skylight well. Do you know what I mean by a skylight well? A skylight well basically is, so you're inside the house and the ceiling is at 10 feet, but the skylight is up at the roof line. So you're walking along and there's kind of this hole in the ceiling and you look up and there's a well going up to the skylight. When you get into the attic and you inspect the attic, understand that those walls on that well are knee walls and they need to be insulated. And oftentimes, one of two things will happen. They'll insulate the attic, and so you'll have 14 inches of insulation up those walls and nothing beyond that. Well, I mean, this is a well, right? It's all the hot air is collecting up in these wells, and there's no insulation keeping it from going into the attic, the heat from going into the attic. The second problem you'll run into is they have insulation, but they've taken blankets and just kind of wrapped the blanket around the well. And so when you get close to the well, you can see underneath and over the top of the blanket of insulation, and that blanket isn't in direct contact with the air barrier. Consequently, there's an air space in between the insulation and the drywall, so that air inside the house warms up the drywall radiates to that pocket of air, that air then rises through convection right past the insulation into the attic, and now you have a thermal bypass. So those are some things you need to look out for when you're looking at skylights and when you're evaluating skylights. A properly insulated skylight well gets treated exactly like a knee wall, okay? You have bats that are cut to the width of the studs so that the insulating bats go into each one of the openings, okay, in between each stud. Then you need to have an air barrier tight around the studs. So if you want more than an R11, then what you would do is put bats in so the bats are no air gaps between the drywall and the insulation. And then you would then wrap with a blanket of insulation that has an air barrier faced, it's air barrier faced, and then you tape so that no air can get in. Gets taped all the way around so that that whole area gets sealed in, no air. The interesting thing about spray foam, if it's closed cell, it acts as an air barrier, right? But if we take and we stuff that opening with fiberglass, what do we get? We get a thermal barrier with no air barrier, right? Now, when the painters came through and painted, their job is to caulk around the window. But this is what they know. They know these two things. They know that most people are not tall enough to see the top of the window. And people who are short enough to see the bottom of the window don't care whether it's caulked or not. So typically you'll see a painter come through, caulk one side, caulk the other side, and move on. Consequently, pay particular attention, especially when you're running your blower door, to underneath the windowsill and over the top of the window. Okay? Check those two places in particular for leaks. And as we discussed, most of the time, unless the window is really poorly built, the window itself is not going to leak. Most of the time when the homeowner is talking about, I feel a draft on a window, what they feel is either the convection created by the coldness of the window, the cold air falling down the window, hitting the windowsill and blowing across the back of their neck, with the couch is sitting up next to the window. Okay, either that's what they're feeling, or they're feeling air coming in around through the rough opening, between the rough opening and the window itself. Sometimes you will find windows that don't shut right or weren't manufactured properly. I happen to have a couple of those in my house. The windows will actually be drafty. In most cases, issues with doors and windows are easy to diagnose and, short of replacement, inexpensive to fix.